For this video, we will be talking about section 5.3, which is scatter plots and lines of fit. To start, we have some vocabulary here, actually quite a bit of vocab here. Our first vocab word is bivariate data. This consists of pairs of values. A scatter plot is a graph of bivariate data that consists of ordered pairs on a coordinate plane. Using a scatter plot can help you see the trend or the general pattern. A line of fit is used to describe the trend of the data in a scatter plot. We will talk a lot about lines of fit on the back side of your notes. And then the last two words we have here, linear extrapolation is the use of a linear equation to predict values that are outside of the range of data. And then linear interpolation is the use of a linear equation to predict values that are inside of the data range. And we will also talk about that more on the back side of your notes.
Next, we need to talk about the different types of correlations there are for scatter plots. So first we have a positive correlation. This is as x increases, y increases. So basically from left to right, what's happening is those dots or plot points are trending in an upward pattern from left to right. That's the biggest point here, is from left to right. A negative correlation, the points would be going down, generally speaking, from left to right. Again, they're not going to make a perfectly straight line. That's why it's called a scatter plot. However, if there's a general trend or pattern, it does have a correlation. Now you'll notice on this one for no correlation, there is no line that I could draw that would show a general shape of those points. So that's why this one would have no correlation. It says X and Y are not related at all. So looking at these examples for 1, 2, and 3, looking at number 1, landline telephones in the US, so years since 2000, and then how many landlines there are. If you don't know what a landline is, that's sorry, I got cut off. That is like a home phone, if any of you still have a home phone. Regardless, they are going away. People nowadays less and less have them. So if you notice right here, it is very, very gradual. But if I was to draw a line that would show the general shape or pattern of those points, this is going in a downward pattern. So this would have a negative correlation. Looking at number 2, this one's not labeled with anything, so we don't really have an X to compare to a Y, but these dots right here are all just kind of all over the place. So we would say that this one has no correlation. Something I do like to bring up that's a good example of something that has no correlation is like your age and your shoe size. Just because you're a certain age does not mean you have a certain shoe size. Those numbers could be all over the place. There's lots of examples of what a no correlation could be, but there's just one for you. And then the last one we have here is the New Orleans Saints 2014 roster, height in inches, and then the weight in pounds. Generally speaking, that is trending upward. Sorry, I got cut off again. Trending upward. So typically the taller you are, the more you weigh. Obviously, we know that there are some exceptions, and so that's why you'll see some of those points are a little bit farther from that line I drew. But typically speaking, that is trending in an upward pattern. So this would have a positive correlation. And that is it for the front side of your notes. We will continue on the back.
Okay, so now we have using a linear function to model data. We have some steps here to follow. Step 1 says make a scatter plot. Well, on number 1, they actually made the scatter plot for you. On step 2, it says draw a line. However, in this example, we really don't have to draw a line because they didn't tell us to. You'll see on number 2, they actually do tell us to draw a line of fit. So you really only have to draw one if they ask you to. So we're going to go ahead and move on to step 3 here on number 1. It says use the data points 10, 20, and 50, 80 to write an equation of the line of fit in slope-intercept form. So just to put this into perspective for you, we need a line that goes through 10, 20, and 50, 80. So that would be the line that we are writing the equation for. And again, you don't need to draw this line, but it's just to give you a visual as to what we're doing right now. So first things first, this is hopefully just a good review for you. Using those 2 points, we need to find the slope first. So 80 minus 20 over 50 minus 10. This would give us 60 over 40. So then we would get a slope of 3/2. If you simplify that all the way. So then I'm going to take one of the ordered pairs. I'm going to go ahead and go with the smaller numbers there. So y minus 20, put it in point slope form, equals 3/2 times x minus 10, and then start converting to slope intercept form. So distribute first, y minus 20 equals 3/2 x. 3 times negative 10 would give us negative 30, divided by 2 would be negative 15. And then we're going to add 20 to both sides. And when we do that, we get y equals 3/2 x plus 5 for our final answer here for writing the equation. Now, this says to predict the amount of milk needed for a 17-pound goat and a 55-pound goat. So, I guess I am just realizing that I never talked about what the scatter plot represented. So this is about a goat feeding based on the weight. They're trying to predict how many ounces a goat would need based off of its size. So the first thing we're going to do is start with the 17-pound goat. So all I'm going to do is plug this in for x in my equation that I solved for. So I have y equals 3/2 times 17 plus 5. If you remember order of operations, you have to multiply 3/2 by 17 first. So we would get 25.5 and then have to add 5. So that answer would be 30.5. And since this is technically a word problem, there's labels here. We have to label our answer with ounces. So a 17-pound goat would require 30.5 ounces. If we were to look at the graph, 17 would be roughly right here. And if I followed that up to on my trend line, that would make sense that it's right above 30 right there. That would be an example of interpolation because it is inside all of your known data values. Now, 55-pound goat would be over here somewhere, and that's actually on the outside of your data. So this would be an example of extrapolation, just to kind of bring that back, those vocab words back in there for us. So we're going to go ahead and plug in 55 for x now. So y equals 3/2 times 55, and then plus 5. This would give us 82.5 when you multiply 3/2 by 55, and then add 5 to that. So we would get a final answer of 87.5 ounces. So that would be what a 55-pound goat would require. So notice that you have two answers here. Make sure you try to stay organized in your way of answering these two questions on part B. Moving on down to number 2. I'm going to zoom in a little bit more here. Okay, now in number 2, they actually give you a blank scatter plot. So step 1 says make a scatter plot. We're talking about the number of minutes spent studying and the test scores that were earned. So minutes is going to go down here for the x-axis, and then test score is going to be my y-axis. Now if I go plot all my points, I have 10, 24 would go about here, 40, 45, 50, 52, 80, and 77 would be about here, 90, 81, and then 188 would be up here. So what we need to do now is draw a line of fit. So something you need to take note of is when we draw this line of fit, we need to make sure that we go through at least 2 points, because we're going to need 2 points to make an equation of a line. And we also want to make sure that it is spread out as evenly as possible. What I mean by that is you have an even number of points that are above the line and an even number of points that are below the line. Now, luckily for us, these points look like they relatively make a pretty straight line. So I'm going to try to start my line about right there. And notice I'm going to play with this until I figure out if I have an even number above and below. So I'm going to actually drop that line right there. That looks pretty good. I have this point that is definitely above the line. I have this point that is kind of below the line. 3 of them are on the line, and I have 1 just above. So I would say that's a pretty accurate representation of my data. And I would say that the 2 points that I definitely go through would be this one and this one. You don't want to pick 2 points that are literally side by side with each other, because that wouldn't be the most accurate or average representation of the data. So I'm going to go ahead and pick those 2 points. That would be the 40-45 point and the 90-81 point. So that is what Part C wants us to write down. Use the data points 40, 45, and 90-81 to write an equation. So we're going to start by finding the slope again. So m equals 81 minus 45 over 40 minus 90. And that would give me 36 over 50. And actually, when you get a really nasty fraction like this, we're going to go ahead and just make it a decimal. And I'm going to go ahead and put that it is 0.72. On number 1, technically we could have used 1.5 and that would have been totally fine. So in scatter plots, it is okay to have a decimal for your slope. It's also okay to have a decimal for your answer like we did on part B for number 1. So moving on here, then you need to pick one of your ordered pairs. Again, I'm just going to go with the smaller numbers here, put it in point slope form. So y minus 45 equals 0.72 times x minus 40. And then I have y minus 45. Go ahead and distribute that 0.72, so 0.72x, and then minus 28.8 when you multiply 0.72 by 40, and then add 45 to both sides. And we get y equals 0.72x plus 16.2. That would be our equation of the line of fit in slope-intercept form. So this blue line right here, the pink equation would be for that blue line there. So now that we have our equation, we can go ahead and predict the test score earned after studying for 30 minutes and 110 minutes. Now, something I would like to point out, if you are looking at 30 minutes, I can look at the graph and actually find where it crosses on the line of fit. So this point right here, I don't actually have to do any work at all. I can go ahead and predict the test score earned after 30 minutes of studying by just looking at the graph. So I'm going to make a note here, look at line of fit. And I'm going to say that that is approximately, we'll go with 38. So a test score, let me erase this 38. I didn't leave myself enough room when I started writing that down. Okay, we're going to say a test score of a 38. We don't know if that's a percent or what it is exactly, so we're just going to go ahead and say a test score of 38. And that was literally by just looking at the line of fit, no math involved. Now, if I wanted to do 110 minutes, and I can't remember if I said the 30 minutes is an example of interpolation because it is inside of your known data values, you're able to look at the trend line for that answer there because it's on the graph. Now, 110 minutes would be an example of extrapolation because the 110 is over here somewhere, and we can't actually look at that on the graph because it is not a clean, this would just be an estimation, and we would rather it be more exact if we can make it more exact. So we're going to go ahead and actually plug it in. So y equals 0.72 times 10 plus 16.2, and that would give us y equals, oh, whoops, not 10, 110. Let's try that instead. There we go. That would give us 79.2, and then plus 16.2 would give us an answer of y equals 95.4, and then we need to also label our answer. So I'm going to scroll down here just a little bit. So we would say a test score of 95.4. Something else I want to talk about really quick as well. This would be an example of a positive correlation, and you could say that the longer you study, the higher the test score is that you would receive. So that is it for these notes.